Embark on a journey through the core concepts of Python programming. This guide provides a structured exploration of essential features, fundamental differences, and practical applications designed for aspiring developers and those seeking to solidify their understanding of Python. Python is recognized for its accessibility and versatility. Its design principles emphasize code readability and a clear, logical syntax. It is an interpreted language, meaning code execution occurs line by line without a separate compilation step. This characteristic often facilitates rapid development and debugging processes. Python supports dynamic typing, where variable types are determined at runtime. This flexibility allows for more adaptable code, though it requires careful attention to data types during development. As an object-oriented language, Python enables the organization of code into reusable objects. This paradigm supports modularity and promotes efficient software design. The language boasts an extensive standard library and a vast ecosystem of third-party packages. These resources provide pre-built functionalities for a wide array of tasks, from web development to data analysis. Python's portability ensures that code written on one operating system can typically run on another without modification. Its open source nature fosters a collaborative community and continuous development. Understanding the evolution of Python is crucial for modern development. Key differences exist between its major versions. Python 3 represents the current and future direction of the language. It introduced several backward incompatible changes to improve consistency and address design limitations of its predecessor. Notable changes include print becoming a function requiring parentheses for its arguments. Integer division now yields a float by default, ensuring more predictable numerical operations. Furthermore, Unicode is the default string type in Python 3, simplifying text handling and internationalization. These updates streamline development and reduce common pitfalls. PEP 8, the Python Enhancement Proposal 8, serves as the official style guide for Python code. Adhering to PEP 8 promotes consistency across projects and within the broader Python community. Its importance lies in enhancing code readability and maintainability. Consistent styling makes code easier to understand, debug, and collaborate on, benefiting both individual developers and teams. Python offers several built-in data structures, each with distinct characteristics suitable for different use cases. Understanding their properties is fundamental for efficient programming. Lists are mutable sequences, allowing elements to be added, removed, or modified after creation. They are ordered collections, meaning elements maintain their insertion order. Tuples are immutable sequences, meaning their contents cannot be changed once defined. They are also ordered and are often used for fixed collections of items. Sets are unordered collections that do not allow duplicate elements. They are useful for membership testing and mathematical set operations like union and intersection. Python's memory management system employs reference counting and a garbage collector. Reference counting tracks how many references point to an object, deallocating memory when the count drops to 0. The garbage collector handles circular references, where objects refer to each other but are no longer accessible from the main program. This dual approach ensures efficient memory utilization. Virtual environments are isolated Python installations that manage project-specific dependencies. They prevent conflicts between different projects requiring different versions of the same library. Using a virtual environment ensures that each project has its own set of packages, maintaining stability and reproducibility. This practice is highly recommended for all Python development. The copy method creates a shallow copy of an object, meaning it duplicates the top-level structure but shares references to nested objects. Changes to nested objects in the copy will affect the original. Deepcopy creates a completely independent copy, duplicating all nested objects recursively. This ensures that modifications to the copied object do not impact the original. List comprehensions provide a concise way to create lists based on existing iterables. They offer a more readable and often more efficient alternative to traditional loops for list construction. For example, x2 for x in range 5 efficiently generates a list of squares 0, 1, 4, 9, 16. This syntax is a powerful feature for data transformation. Python fully supports object-oriented programming, a paradigm that structures software around objects rather than functions and logic. Key concepts include encapsulation, inheritance, polymorphism, and abstraction. A class serves as a blueprint or template for creating objects. It defines the attributes, data, and methods, functions, that objects of that class will possess. An object is an instance of a class, a concrete realization of the blueprint. Multiple objects can be created from a single class, each with its own state. Instance methods operate on specific instances of a class and can access instance-specific data. They typically take self as their first argument. Class methods are bound to the class itself, not an instance, and are defined using the class method decorator. They receive the class as their first argument, CLS, and can modify class-level data. Static methods are associated with a class but do not operate on instance or class data. They are defined using a static method and behave like regular functions within the class namespace. Inheritance allows a new class, subclass, to acquire properties and behaviors from an existing class, superclass. This promotes code reuse and establishes a hierarchical relationship between classes. The super function is used in subclasses to call methods or access attributes of their parent class. It ensures proper initialization and method overriding in inheritance hierarchies. Polymorphism, meaning many forms, allows objects of different classes to be treated as objects of a common type. It enables a single interface to represent different underlying implementations. For example, if multiple classes, e.g. dog, cat, have a speak method, calling animal.speak on an object of either class will produce the appropriate sound. Encapsulation involves bundling data and methods that operate on the data within a single unit, a class. It restricts direct access to some of an object's components, preventing external interference. In Python, encapsulation is enforced by convention using naming conventions. A single leading underscore, protected var, suggests a protected member, while double leading underscores, private var, indicate a name-mangled private member. Dunder methods, also known as magic methods, are special methods with double underscores, e.g. init, str. They allow classes to implement behaviors for built-in operations. Init is the constructor, star defines the string representation for users, repar defines the string representation for developers, and eq defines equality comparison. Choosing the right data structure can significantly impact performance. Dictionaries and sets offer distinct advantages over lists in specific scenarios. A dictionary is preferred over a list when key value access is required, or when fast lookups based on unique keys are essential. Dictionaries provide efficient retrieval of values by their associated keys. The time complexity of searching for an element in a set is typically O1 on average, due to its hash table implementation. In contrast, searching in a list has a time complexity of On in the worst case, as it may require iterating through all elements. Stacks and queues are fundamental data structures. A stack can be implemented using a Python list with append for pushing and pop for popping elements, LIFO, last in, first out. A queue can be efficiently implemented using collections.dk for optimized append and popleft operations, FIFO, first in, first out. Sorting a dictionary by its values or keys involves using the sorted function. This function can take a key argument, often a lambda function, to specify the sorting criterion. For example, sorted D items, key lambda item, sorts a dictionary D by its values. Default dict from the collections module provides a default value for a key that does not exist, preventing key error. Counter is a subclass of dict used for counting hashable objects. To find duplicates in a list, one common approach is to use a set to track scene elements. Alternatively, collections.counter can efficiently count occurrences of each element, revealing duplicates. Generators are functions that produce a sequence of results one at a time on demand using the yield keyword. They are memory efficient as they do not store the entire sequence in memory. Iterators are objects that implement the iterator protocol, iter, and next methods. Generators are a convenient way to create iterators. Enumerate is a built-in function that adds a counter to an iterable and returns it as an enumerate object. It provides both the index and the value in a clean Pythonic way, unlike a standard loop with manual index tracking. Interacting with files is a common programming task. Python provides straightforward methods for file operations. To open a file, use the open function, specifying the file path and mode, e.g. R for read, W for write, A for append. Content can then be read using .read or written using .write. It is crucial to close files after use to release system resources, either explicitly with .close or implicitly using a with statement. The with statement ensures automatic resource cleanup even if errors occur. A context manager is an object that defines the runtime context for a block of code. The with statement is used to manage resources that need to be set up and torn down, such as files or network connections. Exception handling is a mechanism to gracefully manage errors and unexpected events during program execution. It prevents programs from crashing and allows for controlled recovery. The try block contains code that might raise an exception. The except block catches and handles specific exceptions. The finally block always executes, regardless of whether an exception occurred. The else block executes if no exception was raised in the try block. This structure provides robust error management. Custom exceptions are user-defined error types created by subclassing the built-in exception class. They allow developers to define specific error conditions relevant to their application logic. Instead of merely printing errors, the logging module provides a more sophisticated way to record events. It allows for different log levels, e.g., debug, info, warning, error, critical, and configurable output destinations. Python supports elements of functional programming, offering tools for concise and expressive code. Lambda functions are small, anonymous functions defined with the lambda keyword. They are typically used for short, single expression operations where a full function definition is unnecessary. Map applies a given function to all items in an input list or other iterable and returns an iterator. Filter constructs an iterator from elements of an iterable for which a function returns true. Reduce from functools applies a function of two arguments cumulatively to the items of an iterable, reducing the iterable to a single value. A decorator is a design pattern that allows behavior to be added to an existing function or class without modifying its structure. It is implemented as a function that takes another function as an argument and returns a new function. Decorators are applied using the decorator name syntax above the function definition. A closure is a function object that remembers values in its enclosing scope, even if that scope is no longer present. It allows a function to access variables from its lexical scope, even when called outside that scope. Memoization is an optimization technique where the results of expensive function calls are cached and returned when the same inputs occur again. Functools.lru cache provides an easy way to memoize functions in Python. Python is a dominant language in scientific computing and data analysis, supported by powerful libraries. NumPy arrays are fundamental for numerical operations. Unlike Python lists, NumPy arrays are fixed-type store elements contiguously in memory and support vectorized operations, leading to significantly faster computations for large datasets. Pandas is a library for data manipulation and analysis. It provides data frames, which are tabular data structures. Pandas handles missing values using methods like isNull to detect them, fillNA to replace them, and dropNA to remove rows or columns containing them. Lock in Pandas is primarily label-based, used for selection by row and column labels. eloc is integer location-based, used for selection by integer position. Scikit-learn is a machine learning library. Train-test-split divides a dataset into training and testing subsets, crucial for evaluating model performance on unseen data. Grid Search CV systematically works through multiple combinations of parameter tunings, training a model for each combination to find the best performing set of hyperparameters. Pickle is a Python module for serializing and deserializing Python objects. Pickle.dump writes an object to a file, and pickle.load reads an object from a file, allowing objects to be stored and retrieved. A Jupyter Notebook kernel is a computational engine that executes the code contained in a notebook document. It maintains the state of variables and outputs between cells, allowing for interactive and iterative development. Effective project management and deployment strategies are vital for Python applications. Managing dependencies in Python projects is crucial to ensure reproducibility and avoid conflicts. This is primarily achieved through virtual environments and requirements.txt files. A requirements.txt file lists all the Python packages and their specific versions that a project depends on. This file allows pip to install all necessary dependencies, ensuring consistent environments across different machines. Pip is the package installer for Python, used to install packages from the Python package index, PyPI. Conda is a cross-platform package and environment manager that handles packages for multiple languages, including Python, and manages non-Python dependencies. Flask is a lightweight and modular web framework, often chosen for smaller applications or APIs due to its simplicity. Django is a full-featured, batteries-included framework, suitable for larger, complex web applications. Creating a basic REST API with Flask involves defining routes using the app.route decorator. HTTP methods like GET and POST are specified within the route definition to handle different types of requests. Request.args in Flask accesses URL query parameters, e.g. key value. Request form accesses data submitted via HTML forms using a POST request. Deploying a Python web application to platforms like Render or Heroku typically involves pushing your code to a Git repository, e.g. GitHub, connecting the platform to the repository, and ensuring a requirements.txt and a proc file specifying how to run the app are present. Securing a Flask or Dash application involves implementing HTTPS for encrypted communication, validating all user inputs to prevent injection attacks, and storing sensitive information like API keys in environment variables, not directly in code. A WSGI, Web Server Gateway Interface, server is a standard interface between web servers like Nginx or Apache and Python web applications. Gunicorn or UWSGI are common WSGI servers used to host Python web apps in production environments, handling requests and serving the application. Robust testing and effective debugging are integral to developing reliable Python applications. Python code can be tested using various frameworks. Unit Test is Python's built-in testing framework, providing a structured way to write test cases. PyTest is a popular third-party framework known for its simplicity and flexibility. DocTest allows tests to be written directly within doc strings. Unitest is part of the Python standard library, offering a XUnit-style testing framework. Pytest is a more modern and widely adopted framework, often preferred for its concise syntax, powerful fixtures, and extensive plugin ecosystem. Mocking involves replacing parts of your system with mock objects during testing. Unitest.mock is a powerful library for simulating external services, database calls, or complex objects, allowing isolated testing of specific code units. Breakpoints are intentional stopping points in code execution used during debugging. In IDEs like PyCharm or VS Code, setting a breakpoint pauses the program at that line, allowing developers to inspect variable values, step through code, and understand execution flow. Improving the performance of a machine learning model often involves several strategies. These include careful feature engineering to create more informative inputs, hyperparameter tuning to optimize model configuration, and exploring different algorithms that might be better suited for the data. Versioning machine learning models is crucial for reproducibility and deployment management. This can be achieved by incorporating version numbers into model file names or by using specialized tools like MLflow or DVC, data version control, to track models and their associated data. When a Dash app crashes after deployment, debugging involves checking deployment logs for error messages, validating that the data formats and paths are consistent between local and production environments, testing the app locally with production-like data, and isolating the problematic component. Handling dynamic user input in a deployed application typically involves using callbacks in Dash or route handlers in Flask that receive user input. It is critical to validate all inputs on the server side before processing them to prevent security vulnerabilities and ensure data integrity. If a model performs well locally but poorly in production, several factors should be investigated. These include data drift, changes in production data distribution, differences in the execution environment, e.g., library versions, and compatibility issues during model serialization and deserialization. The workflow for going from raw data to a deployed model typically involves several stages: data cleaning, handling missing values, outliers, feature engineering, creating relevant features, model selection and training, rigorous validation using test sets, cross-validation, deployment to a production environment, and continuous monitoring of model performance. This overview has touched upon many fundamental and advanced aspects of Python programming. From its core features and object-oriented principles to data handling, web development, and machine learning, Python offers a robust and versatile ecosystem. To deepen your understanding, consider experimenting with code examples, building small projects, and exploring the official Python documentation. Engage with the vibrant Python community through forums and open source contributions. Your continuous learning and practical application will solidify your expertise.